there again. Welcome back. We're going to take that solving equations work that we did yesterday and we're going to take it one step further and work with proportions. So let's start off with talking about what a proportion is. A proportion is two ratios that equal to each other. So something over something equals something over something. Now before we get into solving for letter A, I want to give a disclaimer. I do not want to so much as hear a peep in my classroom about the darn fish method. It doesn't exist, and unless you know what it truly means and what you're truly doing, you cannot use it anyways. So fish method doesn't exist. If I hear you talking about the fish method or asking why you can't use it, A, that demonstrates why you shouldn't be using something even remotely close to the fish method, and number two, I will tell you to drop and give me 10, and I really will be serious about drop and give me 10 push-ups. Some of you might end up having quite the large guns. So
and if you were to see her face right now, I would say do not use that word at all in the near future or any time within the walls of this classroom.
He's right. So let's go ahead and get started with solving these first two.
So for A, we have proportion of x over 6 equals 1 over 2. I know that 2 times 3 equals 6, and if I do it on the bottom, I have to do it on the top. So we're left with x equals 3.
Some of you might be going, why didn't you just find the cross product? Well, you know what? Why should I do that one? This is so much easier. If I can just see the relationship, I have to do no algebra whatsoever, which would make your life a whole lot easier.
Number B, or letter B, so we got 4 over 14 equals 24 over x. Now, I know 4 times 6 is 24, so I have 14 times 6, which then we're left with x equals 84.
Amazed how quickly we can do our math? Impressive, isn't it? All right, let's look at C. Now we got variables on both sides. So I like to treat this as if it's a giant fraction on the left and a smaller fraction on the right, and variables on both sides. We need to clear that denominator. So I say, okay, what can go into both 7 and, or can 7 and 2 both go into? Well, I say, oh, that's 14. So I'm going to multiply both sides by 14 over 1. And when I do that, now I simplify and I say, okay, 14 divided by 7, that's 2. 14 divided by 2, that's 7. Now I can clean up what I really have, which is 2 times the quantity 3x plus 2 equal to 7 times x. So now, if I divide 7x by 2 to get rid of that 2 outside the parentheses, it's going to get really messy really fast. So here is where I'm going to choose to distribute that 2 in, which will then give me 6x plus 4 equal to 7x. So then I say, okay, I need to get rid of this 6x, so I subtract 6x from both sides. That gives me 1x, or x, equal to 4. Looking at this third one. Now, I can't quite clear the denominator without making it super ultra messy. So instead, I'm going to do a little flipperoo. The nice part about a proportion is it does, as long as the 2 and the 6 are either directly across from each other or above and below one another, and they're not diagonal from one another, we're still correct with our proportion. So I'm going to do a little flipperoo and flip this whole proportion upside down, which means I now have u minus 5 over 2 equal to 9 over 6. Now I can say, okay, what does can 2 and 6 both go into? Well, they can both go into 6. So I'm going to multiply both sides by 6 over 1. And 6 divided by 6, gone. 6 divided by 2, that's 3. So now I've got 3 times u minus 5 equal to 9. Now I can go back to example B from yesterday and remember, well, 3 is on the outside, 9 is divisible by 3, so I'm going to divide both sides by 3 instead of distributing in, which means I now have u minus 5 equal to 3. And then I add 5 to both sides to give me u equals 8. And you know what? No lesson would be complete without having some word problems. So we've got here in a film the 555-foot tall Washington Monument casts a 100-foot long shadow, whereas the main character in the film casts a 4-foot long shadow. Why is this film considered a goof? So we need to figure out how tall this main character is. So we draw a picture. We've got the beautiful Washington Monument all over the top, the windows. This thing is 555 feet tall, and it casts this one beautiful 100-foot long shadow. Meanwhile, we got our little person. Yes, it's not drawn to scale. We don't know how tall they are, and they're casting a 4-foot long shadow. So we set our proportion up and how they match up. We know that the monument is 555 feet tall, and they cast a 100-foot long shadow. And we don't know how tall the person is, but they cast a 4-foot shadow. I look at this, and I say, oh, I know that to get from 100 down to 4, I can divide by 25. I always want to head in the direction of the variable. So if I take 555, I need to divide that by 25. I know that, so I'm going to start doing this because since that's not asking me how tall the person is, we can just start getting an idea. 25 goes into 55 twice, that's 50. So there's 5 left over. So then that means that 25 goes into 55 again twice. This is already saying the person is 22 point something feet tall. Doesn't matter what that point something is. It's considered a goof because no person is 22 feet tall. So I'm going to draw my person so I don't have to write person. Is 22 feet tall. Oh my goodness, that would be a huge person. So what I have for you now is some practice. You got these two proportions that I want you to solve. And then I've got this shadow problem with we have a 6-foot tall climber casting a 20-foot shadow with a tree casting a 90-foot shadow. I want to know how tall that tree is. So set up your proportion and solve it. And as always, bring your questions with you to class tomorrow.